In this video, I am going to talk about homogeneous differential equations. As you probably remember, the definition of a homogeneous differential equation is this: dy over dx is equal to f of y over x. That means if you have a differential equation that could be expressed in this format, where the derivative of the dependent variable y with respect to x is equal to some function of y over x. Here y over x, you can think of it as a single input. Okay. Now there is another variation of this definition, which is m of x comma y times dx plus n of x comma y dy is equal to 0 is a differential equation that is homogeneous given that m of xy and n of xy are both homogeneous functions with the same degree. All right, having said that, let's go ahead and solve the given differential equation, which is y prime or dy over dx is equal to x minus y over x plus y. So dy over dx is equal to x minus y over x plus y. And we can, by the way, solve this by converting the right hand side into this format, f of y over x. In order to do that, we divide both numerator and the denominator by x. So what we're going to get, x minus y divided by x and x plus y divided by x. And if I did that, I'm going to get 1 minus y over x divided by 1 plus y over x. Now I'm going to make a substitution. So the substitution is going to be, let's say, v is equal to y over x. That gives me y is equal to v times x. That means dy over dx is going to be v times derivative of x dx over dx, which is just 1, plus x times derivative of v dv over dx. And if I were to simplify it, I would get dy over dx is equal to v plus x times dv over dx. Okay. Now let me go ahead and substitute this value. So I have had dy over dx is equal to 1 minus y over x divided by 1 plus y over x, which is from this line we get. Now dy over dx, which is this, and this is the same, so I'm going to substitute the value v plus x times dv over dx. And our assumption was that v is equal to y over x, so that's going to make the right hand side 1 minus v divided by 1 plus v. And let me go ahead and simplify it further. So x dv over dx is going to be 1 minus v divided by 1 plus v minus v, right? Minus v. So I'm going to multiply and divide it by 1 plus v to have the common denominator, 1 plus v. And that is going to give me the following: dv dx, x dv dx. On the left, it doesn't change. On the top is going to be 1 minus 2v minus v square. 1 minus 2v minus v square, and you can divide it by 1 plus v. Now I'll go ahead and do some simplification here again, and that's going to lead to the following. You're going to have 1 plus v over 1 minus 2v minus v square times dv is equal to dx over x. Now I can integrate both sides. By the way, in going from here to here, I just did basic algebra, and you know how to do it. Multiply both sides of this equation by the reciprocal of this, and then just simplify it. Now, the integral of right side is pretty straightforward, which is just the ln of x. But integral of the left side just needs a little bit of substitution, and that's pretty easy. So let me go ahead and do it here on the side and see what I get. So integral of the left side is left side is this. Integral 1 plus v dv over 1 minus 2v minus v squared. And let's make it just substitution. Let's say u is equal to 1 minus 2v minus v squared. That's going to give you du over dv is equal to negative 2 times 1 plus v. Okay, it's going to be negative 2 times 1 is negative 2, then minus derivative of v square is just 2v. So if I factor it out, that's going to give me negative 2 times 1 plus v, and then I get negative 1 half du is equal to 1 plus v dv. Now, if I substitute this value, so there is a 1 here I missed. If I substitute this value into this one, I'm gonna get negative 1 half times integral du over u, which is nothing but negative 1 half times ln of absolute value of u. But remember, u is this value, so it's gonna be negative 1 half times ln of absolute value of 1 minus 2v minus v squared. And I'm going to go ahead and plug it back in here to get the final solution. So the left hand side evaluates to negative 1 half times ln absolute value of 1 minus 2v minus v squared is equal to ln of absolute value of x plus some arbitrary constant c. And I'm going to go ahead and simplify this now. Now this simplification can be done in multiple ways. I'm just going to go ahead and do it this way. So multiply both sides by negative 2. That's going to get rid of the negative 1 half on the left. Okay. And then on the right hand side, we are going to have something different. So let's go ahead and do this. Ln of absolute value of 1 minus 2v minus v squared is equal to negative 2 times ln of x absolute value minus 2 times c, that I could simplify further to ln of 1 minus 2v minus v square all under absolute value is equal to ln of x to the power absolute value of x to the power negative 2 minus 2c. Now if I apply exponential to both sides, okay, exponential function and natural log are inverses of each other. So if I apply exponential to both sides, so exp to this side and exp to that side, on the left hand side, exponential and natural log, they're going to cancel each other. That's going to leave me behind with 1 minus 2v minus v square is equal to e to the power ln of, just I'll put x square. I'm assuming that we are dealing with real numbers here only for the sake of argument. Times e to the power negative 2c. Now again, exponential and ln, they're inverses of each other. They will cancel each other out. So that's going to leave me behind 1 minus 2v minus v square on the left as it was. And these two are going to cancel each other out. That's going to give me x square times e to the power negative 2c. Now v is actually y over x. So if I were to put that value back in, I'm going to get 1 minus 2 times y over x minus y square over x square is equal to x square e to the power negative 2c, right? If I were to multiply both sides by x square, I would get x square minus 2xy minus y square on the left is equal to x square times x square is x to the power 4. Now e to the power negative 2c, it's a constant. I am going to write it first and then times x to the power 4. And I think this is probably a reasonable place to stop and kind of leave the answer in this format at this stage. You could simplify it further if you really wanted, but I'll be happy with this. I hope that this discussion was helpful, and thank you very much.